Many students fail physics not because it's hard, but because no one taught them how to think. In the next few minutes, I will show you a simple method you can use to solve any physics problem, even if you hate physics. Let's crack the code. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host, Josh White, and it's my mission to help you crush high school with confidence and clarity. Please do well to hit the subscribe button, turn on the notification. Let's get started. In this video, I will be showing you 7 steps that works for any physics problem. And at the end of this video, we will practicalize it by solving questions from JAMB and SSCEs using these laid down steps. Step number 1, identify the topic. Whenever you see or come across a physics problem, you should be able to identify the topic of that problem. You are truly in a problem if you can't identify the topic of a problem. Step number 2, understand the story that problem is saying. You see, every physics problem is actually telling a story. Let's say, for instance, you see a question that says a car starts from rest. Yes, that's a story that needs to be analyzed. It means that the initial velocity, since it's starting from rest, the initial velocity is what? Yes, 0 meter per second. Or you hear that the train come to a halt. It means the final velocity is what? 0 meter per second. So understand the story of the problem. You see, it is in this area many students miss it because they know order of the steps, but they are not able to analyze the problem adequately, so they miss it up. Step number 3, write out the data. Whenever I come across a physics problem, what I do first is write out the data. If you are able to write this down, as I always do whenever I come across a physics problem, it makes it easier for the next step. Let's move on. Step number 4, choose the formula from your formula bank that best suits the aforewritten data. Now, if you desire to know how to develop a formula bank, please do well to watch the video that I made on how you can master physics formulas easy. So on every topic in physics, you should have a formula bank. If you've identified the topic, you should have a list of formulas. So from that formulas, pick out the formula that contains the data you've written. That will possibly be the most suitable formula to use. Step number 5, substitute the data into the formula you have chosen. So after you've brought out the right formula, then substitute those data from the question you have into the formula. Number 6, solve. So having substituted, calculate it. And lastly, step 7, get your answer and insert the right unit. Please take note, in physics, Units is very important. Putting wrong units for a particular question is as failing that question or not getting the full mark allotted for it. So you must know. If, for example, you are calculating power, what's the unit? Watt. You are calculating potential difference or electromotive force, what's the unit? Volt. You are calculating work done or energy, what's the unit? Joules. So you must, at the end of your calculation, put the right unit. So my fingers are itchy. If you don't mind, let's practicalize these steps. Let's go to class.
Okay, welcome back, future rockstars. Now we will be practicalizing what we've learned using physics questions. Now, here are our listed steps. Identify the topic, understand the story behind the topic, write out the data from the question, use the right formula, substitute, solve, then get your answer and insert your unit. So we will be looking at this question. A metal rod has a length of 100 centimeter at 200 degrees Celsius. At what temperature will its length be 99.4 centimeter if the linear expansivity of the material of the rod is 2 exponential minus 5? So here are our options. Now, what topic is this? I believe this is linear or linear expansivity, which is a subtopic under expansion of solids. Now, from this question, I can infer that there is an initial length of the rod, then the length became this new length. When this level of temperature was added, the linear expansivity of the material is this. So by that, we understand the story behind the question. Okay, the next step now is for us to write out the data. Now from our question, our initial length is 100 centimeter. Then our final length, L2, is 99.4 centimeter. Our temperature, our initial temperature is 200 degrees Celsius. And our linear expansivity is 2 exponential minus 5. And we are being asked to find our final temperature. Now, we've well listed all the data in this question. Now, the next thing is use the right formula, selecting the appropriate formula that best suits our afore listed data. Now, the formula for linear expansivity is equals to change in length all over initial length multiplied by change in temperature. Now, that's our appropriate formula. The next thing is substitute this data into the formula. Now, our linear expansivity is 2 exponential minus 5 is equals to our final length is 99.4 minus 100 all over our initial length 100 multiplied by the rise in temperature, which is the final temperature minus the initial. That's theta 2 minus our theta 1 now is 200 degree. Our 2, let's just use that as 200. Now the next thing is just to solve. Now this will give us, by opening the bracket, it will give us 2 exponential minus 3 theta 2. I will be jumping steps for the want of space, minus 0.4 is equals to 99.4 minus 100 will give you a 0 minus 0.6. Now, collecting like terms, 2 exponential minus 3 theta 2 is equals to minus 0.6 plus 0.4. So, 2 exponential minus 3 theta 2 is equals to minus 0.2. So, dividing both sides by the coefficient of final temperature, which is 2 exponential minus 3, 2 exponential minus 3. Now, when you solve this, it will give you minus 100. That's our answer. Then our unit is what? Degree Celsius. As simple as that. Let's take another question. A palm fruit dropped to the ground from the top of the tree, 45 meters tall. How long does it take to reach the ground? So what topic? This looks like motion, equation of motion. So what story is this telling? A palm fruit dropped from the top of a tree. If that fruit is dropped from the top of a tree, that means that fruit must be in an initial velocity of 0 because the fruit must be at rest. That means we know if there will be u will definitely be a 0. And how long does it take to reach the ground? That means we are being asked to find time. The next thing, our data. Our height is equals to 45 meters. We're giving G as 10 meters per second square. And we are being asked to find time. We know that our U is equals to 0. So now, these are the data in this question. Now, which formula best suits this data? From our 4 or 5 equations of motion, I believe the one that best suits our data here is H is equals to UT plus 1 over 2 GT squared. Remember, this can be plus or minus based on the nature of the question. So now our next step is substituting this data into this equation. Now, our H is 45, U multiplied by T plus 1 over 2, 10T squared. Are you seeing it? So now, let's solve. 45 is equals to 0 plus 1 over 2. So this will give us 5t squared. So coming to this new place, so it is 45 is equals to 5t squared. Divide both sides by 5, divide both sides by 5. Our t squared is equals to 9. Square root both sides. So our t will be equals to square root of 9. Our t is equals to 3. Answer. Unit of time is what? Second. So our answer is what? This. Let's go to the next question. A car of mass 1,500 kilograms goes round a circular curve of radius 50 meters at a speed of 40 meters per second. The magnitude of the centripetal force of the car is, and our options, co-opted from UTME 2007, question 44. So, same principle. Identify the topic. This looks like circular motion. Then, what is the story behind it? I know that there is a mass here, and the mass moving through a circular curve whose radius is 50 meters. And in the question, I am meant to find the centripetal force. So now our data. Mass is equals to 1,500 kilograms. Our radius is equals to 50 meters. Our velocity is equals to 40 meters per second. And we are asked to find our centripetal force. Simple. Now I have brought out this data. Now, identify the formula won't be a problem if I have mastered the formula already. So now, which formula best suits this data? I know of a formula. Centripetal force is equals to mv squared over r. Mass multiplied by the square of velocity divided by the radius. Now, let's substitute. So, Fc is equals to our mass 1500 multiplied by our velocity square 40 square divided by our radius 50. This will give us 1500 multiplied by 1600 divided by 50. Our answer is D. Simple. Let's try one more. A temperature of 60 degrees Celsius is equivalent to, so I believe this is temperature. The topic is temperature or temperature conversion. And from this question, I can infer that they desire me to convert degree Celsius to possibly degree Fahrenheit. So that's the story this question is saying. Now, what's my data? The only data I have here is our temperature, which is in Celsius, which is equal to 60 degrees Celsius. And we have been asked to find it in Fahrenheit. So that's just the data. So, what's the formula? There are other ways I can solve this, but it has a formula also. Now, degree Fahrenheit is equal to degree Celsius multiplied by 1.8 close bracket plus 32. Now, the next thing is what substitute. Let's put our data into our formula. So we are looking for degree Fahrenheit. Our degree Celsius is 60 multiplied by 1.8 close bracket 32. So 60 multiplied by 1.8, then plus 32. So our degree Fahrenheit is equals to 140 with our unit. 140 degrees Fahrenheit. So our answer is what? B. So future rockstars, physics is not difficult. Follow these steps. Whenever you see a question, identify the topic. That helps you to be able to know the lines of formulas that are the possibility of that question. The next thing, understand the story that question is saying. As I said previously, many students miss it at this point because of, even if you know the right formula, know how to solve it, and you misinterpret the examiner's thought, you will still get the wrong answer. And can I surprise you? You will see the option there, and you will think that's the right answer, whereas the examiner knows how student thinks. So understand the story the question is saying. Next, bring out the data from the question. Then identify the most appropriate formula that best fits that data. Then the next thing to do is substitute it, solve it, get the answer, and then pen down the unit. So if you gained something from this video today, please do well to share, to like, to subscribe, turn on the notifications so you can receive more updates from us. I am leaving to return another day. I remain your host, Joshua. Peace out.